The chord theorem says that the angle between the tangent to a circle and the chord drawn from the point of contact is equal to the angle in the alternate segment. Let us unpack this theorem and understand what it means. We need to identify a few things. Number one is the tangent. The second thing is the chord. Notice that as the theorem states, the chord is drawn from the point of contact of the tangent to the circle. Now between the tangent and the chord there is an angle. In this case, the size of the angle is x. Now if the chord subtends an angle x at the circumference as shown in the diagram, then it follows that the angle between the chord and the tangent is equal to the angle subtended by the chord in the alternate segment. Let us see how this theorem appeared in past exams. In May 2023, on question 8, we had this diagram. Now we need to identify the different pieces that build our theorem. First, we have the tangent, ST, and second, we have the chord, KT. The third thing is the angle between the tangent and the chord, which in this case is T1 with a size of 36 degrees. And then the last thing to identify is the angle in the alternate segment, L. So this is how the chord theorem looked like in this diagram. Therefore, by the chord theorem, we can conclude that T1 is equal to L and they are both equal to 36 degrees. In November 2022, we had another case, and again we need to identify the pieces that make up our chord theorem. First, we have the tangent, KP, followed by the chord, SP, and then we have the angle between the tangent and the chord. In this case, it is P1. And lastly, we have the angle in the alternate segment, that is Q1 in this case. Those are the building blocks of the chord theorem. In May 2022, again we had all the building blocks for the chord theorem. We had the tangent, EC, we had the chord, BC, and we also had the angle between the tangent and the chord, C1, and lastly we have the angle in the alternate segment, D2. So the angle C1 should be equal to D2. And lastly, in November 2021, there was an interesting question where we were asked to prove the theorem which states that DFK is equal to E. The angle DFK is equal to the angle E. Now we are going to walk through the proof as it was presented in the memo. The first thing, step number 1, was to construct the radii DO and OF. Once we have constructed, we do the following. First, we observe that angle OFK is equal to 90 degrees, and the reason for this is that the angle OFK is at the point of contact of a radius and a tangent, and we know from another theorem that the radius is perpendicular to the tangent. Therefore, the angle OFK is 90 degrees. Next, if OFK is 90 degrees, then the angle DFK must be equal to 90 minus the angle OFD. If we look carefully at the diagram, we can observe this. Then the next step is that the angle ODF is equal to the angle OFD. This is because if you look at the triangle ODF, you can see that it is an isosceles triangle because OD and OF are radii. Therefore, the angles opposite the equal sides of a triangle are equal. That is why the angle ODF is equal to the angle OFD. The next step is that the angle DOF would be equal to 180 minus 2OFD. This is because if we look at the triangle ODF, we know that the angle ODF and the angle OFD are equal, so we can say both of them are equivalent to OFD, and we know that the angles inside the triangle add up to 180. So if I know the angle ODF is equal to the angle OFD, then the angle DOF would be equal to 180 minus 2 times OFD. The next thing to see is that the angle DEF would be equal to 90 minus OFD. This comes from the theorem which states that the angle at the center is double the angle at the circumference. We can see that the angle DOF is an angle at the center, therefore it is double the angle at the circumference, which is DEF. So how do we get 90 minus OFD? We get that by dividing 180 minus 2OFD by 2. Now it is important for us to connect the first statement which says DFK equal to 90 minus OFD and the next statement which says DEF is equal to 90 minus OFD. You can see that DFK has the same result and DEF has also the same result. Therefore, we can connect the two. We can connect DFK and DEF by concluding that DFK is equal to DEF because they are both equal to 90 minus OFD.